Hello, physics students. This is one more example of a complex problem that deals with balanced forces. So go ahead and read the problem and then try the problem. Start with the free body diagram, but pause the video before you do that because after you solve it, you can play the video and see if you got the answer right. So go ahead and pause the video. So let's see how you guys did. Let's start with the free body diagram. So we have the weight by the earth on the crate, and then we have the normal force by the ground on the crate, and then we have friction, which is going to the left because friction opposes motion, and that's going to be pretty long, and we'll find out why in a sec. We also have Henry, which is right there, who's pushing the crate. And last but not least, we have our diagonal force, which is, I'm just going to go through that, tension by the rope on the crate. That's our free body diagram, and the first thing I want to do when I see a diagonal force, if you remember from the last video, is draw the vertical and horizontal components. So I'm going to call that Ty, and I'm going to call this Tx. So really quickly, I want you guys to be sure to keep the Tx here and this normal force by Henry on the crate separate from each other, because in the past I've seen students confuse this Tx with the Henry force, or think that they're equal to each other all the time, or think that they're the same force, but actually they're different because this Tx is a component of this force, whereas this Henry, this normal force by Henry, is a separate force altogether. So just going into the problem, I want you to keep that straight. So now that we've drawn our free body diagram, we can start to find the components of this diagonal force, because that's going to be really helpful when we go back to solve. So this was 33 degrees, and the tension was equal to 510 newtons. So using trigonometry, we can find Ty and Tx, and when we do the math, we use sine of 33 for the Ty, and that comes out to 277.76 after we've done the trigonometry. And when we solve for Tx, we use cosine of 33 is equal to that Tx over the 510, and we get 427.72. That's Tx. Alright, so where are we at? Well, now we can sort of ignore this tension for now, because we've already solved for the vertical and horizontal components. So what are we looking for? Well, number one asks us, how much force is Henry, the sun, pushing with? Okay, so that's looking for this force right here. So how do we find that? Well, we know that this is balanced because it told us that it was moving at constant velocity. So we know that this normal force by Henry plus this horizontal right vector here, the Tx, has to equal the friction. And the problem told us that the friction is equal to 712 newtons. So if I set up a little equation for horizontal forces, I'll just do this. We know that friction has to equal Tx plus the normal force by Henry on the crate. So that is 712 equals Tx, which was 427, plus normal force. And we come out to normal force Henry on crate is equal to 284.28 newtons. So that's our answer for number 1. Okay, number 2 says, how much weight is the Earth applying on the crate? So now we're dealing with the weight force. So this is what we're trying to find. So it also gives us an important piece of information. It tells us that this normal force is equal to 200 newtons. That's really helpful because if I look at my ups and downs, my two vertical forces that are going up are the normal force by the ground on the crate and this Ty. So because it's balanced, they have to equal this weight. So again, I can set up sort of an equation. Normal force ground on crate plus Ty, which I got by doing this plus this, is equal to my weight, which is here. And that will be 200 plus 277.76 equals W. And we end up with 477.76 newtons. So those are our 2 answers. And if you got something wrong here, please try and figure out where it came from. Was it a calculation error? Was it the free body diagram that was wrong? And if we see here, we might have to make our weight a little longer actually to make it accurate. But other than that, I think it's pretty good. So please write down any questions you have and don't be afraid to ask them. Thanks. Bye.